In this session, we are going to look at a chapter called mole concept, and I'm going to talk about what is a mole. Mole is actually a very easy chapter, mole concept, and also as far as ICSE exam is concerned, it carries many marks, around 15 to 20 marks will come. All those marks will be in terms of numericals, and children will find it very difficult to answer those questions just because they do not really understand the concept of mole and also some concepts related to it. But if those concepts are clearly understood, and solving them will be easy and also very scoring. So in this lesson, we will talk about a subtopic of mole concept, that is what is a mole, and we will try to see how to solve the problems that are related to mole. Let's understand what is a mole first. Mole is just a number which is used in chemistry. There is nothing more to it. Okay. Usually in chemistry we encounter very large numbers. For example, a number like this, 10 power 23, which is a very big number. So for example, let's take a dozen. So which means 12. So you don't always say bring me 12 eggs, bring me 12 bananas. Instead of saying that, it will become very easy to say get me dozen of eggs. So this name that is called dozen is given to a number 12. Similarly, mole is a name given to a number 6.023 into 10 power 23. As simple as that. Beyond that, there is no rocket science involved here. This number is also known as Avogadro number, which is actually represented by capital N subscript small a. So mole simply means a number which is equal to 6.023 into 10 power 23. So these many number of particles, these many number of atoms, these many number of molecules. So that is called a mole of atoms, mole of particles, mole of molecules, etc., etc. Since in chemical reactions, the number of atoms or number of particles which take part in the reaction are very huge. So those huge numbers, we cannot simply say that, okay, 6.023 into 10 power 23 molecules of oxygen is reacting. You cannot say that. Instead of saying, we can simply say 1 mole of oxygen is reacting. That way, that makes the life very easier. So that is the whole purpose of mole. But what actually the most important part in the moles is, how do you calculate the number of moles? These kind of questions will come during the examination. So either directly or indirectly. Students will find this extremely confusing because they clearly do not know what is the formula, what are the number of formulas that are there, and which formula should be applied for which problem. So that is the source of confusion. In this video, let me just try to make it very easy and very simple. There are only 4 formulas that are related to calculating number of moles. Only 4. If you know these 4, you can clearly solve any problem that is related to calculation of number of moles. What are those formulas? For example, if an atomic substance is given to you and you are asked to find out number of moles, small m, and then you should use a formula mass divided by gram atomic mass. So mass should be in grams, and also the atomic mass of that particular element whenever an atom is given. So that particular atom. For example, if I say carbon, so then whatever the gram atomic mass of carbon, that you need to substitute here, which is 12 there. And also mass in grams will be given in the question. We will look at some examples, and that time it will become very easy. So the first formula is mass divided by gram atomic mass. Instead of atomic substance, if you are given a molecular substance, for example O2, N2, CO2, CO, such kind of molecules are given, then you need to use a formula which is very similar to the previous one, that is mass divided by gram molecular mass, because now we are talking about molecule, not atom. So that is why atom will be replaced by molecule. So gram molecular mass. So that's the formula that you should be using. The third formula is, for example, if the number of particles are given, let's say in a gas, these many number of particles are there, then that number of particles will be equal to how many number of moles. So you should use a formula called number of moles is equal to the number of particles divided by Avogadro number Na. For example, if a gaseous substance is given and a volume is given to you, So the formula that you should be using is number of moles is equal to volume in liters divided by 22.4 liters. So these are the four formulas. Depending upon what kind of a substance that is given or what kind of an information that is given in the problem, you should apply that particular formula, and then calculating number of moles will be equal. So if an atom is given, then mass divided by gram atomic mass, molecule is given, mass divided by gram molecular mass, number of particles are given, thus number of particles divided by Avogadro number, and then volume is given, volume divided by 22.4 liters will give you the number of moles. Let's understand all these four with a simple examples, and it will become extremely clear to you. Let's calculate the number of moles in 36 grams of carbon. So what is the formula that we should be applying? So we need to know about carbon. Carbon is an atom. Okay, mass is given. So the formula is mass divided by gram atomic mass, which is 36. Mass is equal to 36. Atomic mass of gram atomic mass of carbon is 12. So 36 by 12, which is equal to 3 moles. That means 36 grams of weight is equal to 3 moles. And also other way of understanding is 1 mole is not only equal to, in the previous slide we have seen, 1 mole is equal to 6.23 into 10 power 23 number of particles. That is also equal to gram atomic mass. So each gram of carbon here, so if you see each gram, that is each mole of carbon will weigh 12 grams. So 1 mole of carbon is equal to 12 grams. 12 grams. So since 36 grams are there, 36 divided by 12, that will be 3. Okay, calculate the number of moles in 88 grams of carbon dioxide. So carbon dioxide is what? It's a molecule. So since it's a molecule, you need to use the second formula, that is number of moles is equal to mass divided by gram molecular mass. Okay, the mass is 88. But how do you calculate the gram molecular mass of carbon dioxide? So carbon dioxide is effectively nothing but CO2. Carbon weighs 12 grams. So the weight atomic mass of carbon is 12. Whereas oxygen, it is 18. But you have two molecules of 18. 2 oxygens are there. So 2 into 18, which is equal to 36 plus 12. 2 into oxygen is 8. Oxygen is 8. So that is 16. Atomic number is 8, and then atomic mass is, oxygen atomic mass is 16. So you have 2 into 16, because there are 2 oxygen atoms. So each atom weighs 16. 2 oxygen atoms weighs 32. 32 plus 12. Overall carbon dioxide gram molecular mass is 44. So that is how you need to calculate the gram molecular mass. So you have weight as 88, gram molecular mass as 44. So 2 moles is the number of moles. When you divide it by 88 divided by 44, you will get 2 moles. Let's look at the third example. Calculate the number of moles of oxygen if it has 60 into 10 power 23 particles. So it is a particle. So if you have a 60 into 10 power 23 particles of oxygen, so that is equivalent to how many moles? So moles is equal to, you need to use a formula called number of particles divided by Avogadro number. Number of particles are 60 into 10 power 23. Your Avogadro number is equal to approximated to 6 into 10 power 23. This is 10 power 23. So the exact number is equal to 6.023 into 10 power 23. So when you divide 60 into 10 power 23 divided by 6.023 into 10 power 23, you will get approximately 10 moles. So it is equivalent to 10 moles. The last formula is calculate the number of moles of carbon dioxide if it occupies 89.6 liters. Now volume is given, a gaseous component, and volume is given. When volume is given, what is the formula for number of moles? Number of moles is equal to volume in liters divided by 22.4. What is the volume in liters that is given? 89.6. What is, you substitute 22.4 as it is, and then when you divide both of them, you will get 4 moles. So 89.6 liters is equal to 4 moles. So that is how you should be calculating the number of moles given an atomic substance and gram atomic weight, molecular substance at gram molecular weight, and then you have number of particles and you have the volume given.